A thin needle strikes a sheet of glass. It seems impossible. The needle is small. The glass is hard. Yet under the right conditions, the needle can pass through, leaving a sharp hole and a circle of cracks. This kind of demonstration looks like a trick, but the physics is not supernatural. It is pressure, speed, and brittle fracture. Glass is hard, but hardness is not the same as toughness. Hardness means a material resists scratching or indentation. Toughness means it can absorb energy before breaking. Ordinary glass is hard but brittle. It does not bend much before it fails. When stress becomes too concentrated in one small region, a crack can begin. Once the crack starts, it may spread quickly through the material. A needle has a very small tip. If it hits glass slowly, it may simply bend, bounce, or fail to penetrate. But if it moves fast enough and remains aligned, its force is concentrated into an extremely small area for a very short time. The local stress can exceed the strength of the glass. The glass cracks. This is similar to what happens when a bullet hits glass, but the energy is much greater. A bullet carries large kinetic energy because it has mass and high speed. When it strikes ordinary glass, the impact produces intense local stress. Cracks spread outward. Fragments fly. The glass may shatter. The bullet does not pass through because glass is soft. It passes through because the impact creates failure faster than the glass can distribute the energy. That is why the fracture pattern matters. Radial cracks may spread outward from the impact point. Circular cracks may form around it. The exact pattern depends on glass thickness, impact speed, angle, and support. Bullet-resistant glass uses a different strategy. It is not just strong glass. It is usually a layered structure. Hard glass layers resist the incoming projectile. Flexible plastic layers, such as polycarbonate, stretch and absorb energy. They also hold fragments together and reduce dangerous flying shards. The goal is not to make the bullet disappear. The goal is to spread and absorb its energy before it passes through. Each layer changes the bullet's motion. The bullet may flatten, it may slow, it may deform. The glass may crack, but the plastic layers keep the structure from failing all at once. There is a common misconception that protection means making something simply harder. Hardness helps in some cases, but it is not enough. Very hard materials can be brittle. A protective material must manage energy. It must resist penetration, delay fracture, spread force, and keep broken pieces from becoming new hazards. A needle through glass and a bullet-resistant window are opposite lessons from the same physics. The needle concentrates stress to break a brittle surface. The protective window spreads stress to prevent complete failure. One tries to pierce, the other tries to absorb. In both cases, the important question is not only how large the force is, it is where the force lands, how fast it arrives, and how the material responds before the crack can run free.